Yeah, there. Am I audible?
Yeah, sir.
Perfect. When a bar magnet is placed at 90 degrees to magnetic field, it is acted upon couple which is maximum. For the couple to be half of maximum value, what angle should be magnet be inclined to magnetic field P? Now what they're saying, place the 90-degree to the uniform magnetic field and it is acted upon by couple which is maximum. For the couple to be half of the maximum value, what angle should be the magnet be inclined to magnetic field B? So we know tau equals to mb sine theta. So if theta is 90 degree, then tau maximum will become mb,
MB.
and they are saying half of it. So simple, tau max will be by 2 equals to mb sine theta.
Theta by 2.
Yeah. So this we can divide. This will become 2. This is equals to T max. This is equal to T max. So T max, you can cancel. It will become 1 by 2 sine theta. So theta is 1 by 2 when it is 30 degree. Simple.
Yeah.
It's very, very simple. Let's see some more question. A bar magnet has magnetic moment 2.5 joules per Tesla and is placed in magnetic field of 0.2 Tesla. Calculate work done turning. Oh, easy. Turning the magnet from parallel to position. You can start doing relative to field direction. You can start doing. It's easy. Come on. So you got it right. W equals to MB. If it is 2, then theta 1 minus.
Theta 2.
So first case it is parallel and another anti-parallel. So one is 0, another one minus 0. So your 1 minus of minus 1 will become 2. Simple. So W equals to twice of MB.
Yeah, sir, I got it.
2 into MB is how much? 2.5, and this is 0.2. 2.5 means 5 into 0.2. 5 into 0.2 is 1. 1 joule. That's it over. Finish.
I got it as 1.35. Like,
So it will be exactly 1 now, because we have exact values.
no,
Here 2.
it's 0.27, right?
2 Tesla.
Okay. Yeah, it's 0.27.
Oh, okay. Another one. This is also easy question. This is a direct question. Fine. Okay, then let's study next thing. Field of a magnet. Now, axial line. If it is at axis, means this point. Like same way. See, all this derivation is similar to your first chapter. Whatever we have studied, the same way. So it is on axis of it at some point on the axis. So what will be the magnetic field for that, or magnetic induction for that? So it will be magnetic induction at a point that is on axis. Let's write also, or axial point. So B axis equals to mu naught by 4 pi 2 md by d square minus L square. We are not doing a derivation because it's similar to the same one, the first chapter. Now L is the length of this points, axis point, the dipole points. So if it is a short magnet, L is very, very small than D. So BA equals to mu naught by 4 pi 2m D, and this D square. This will become D to the power 4, and one more D is there. So it will become 3. For condition is that if it is this one, but otherwise general or standard formula is this one. And next is your equatorial point or equatorial line. For equatorial line, same thing, whatever we wrote, we can write that same thing at a distance d, from center will be like B, what we wrote here, BA, then BE, let's write here, mu naught by 4 pi. It will become M d square plus L square to the power 3 by 2. In the same way, if L is very, very small than D, then B will become mu naught by 4 pi M by D cube. Make a note of both.
So can you scroll down a little bit? I'll just copy the last part.
Okay. Oh, this one also done, right? Upper one.
Yeah, I've done that. I just need the equatorial part. Yeah, sir, done.
Okay. Now for standard equation, see this all our equation, if you remember, it's same we are getting. No much difference from this one and the that electric field one, magnetic field, electric field. So in this one also we'll have one like standard value of any point. One question like or at any point. Plane of axial and equatorial three cos squared theta plus 1 by dq. Now this is standard value, standard formula for everything. So if theta is 0 degree for, it will become for axial point or axial line. If theta is 90 degree,
It will be
it will
equatorial.
exactly, because like it will be forming this angle.
Yeah.
Equatorial. Next is your force between two magnets. We'll consider force between two magnets. Now, when some magnet is placed on some other one, okay, so obviously it will have either attraction or repulsive. So either they will attract or they will repel. They will have some force like that. That's what we are going to see, like how much force and what all things, what is the strength of this, what is magnetic induction. So suppose, first let's see condition. Magnets are along the line joining their centers. Okay, so if like suppose magnets are along the line joining their centers, that means what? two opposite poles of magnet, they are facing each other. That's what it means. Suppose if we take some M1 for the one side and another for M2. Okay, they're facing each other. They place at center some common center here. So for that, magnetic field for the first one, magnetic stand for the first one, it will be mu naught by 4 2 M1 by R cube. Intervals with the theta equals to 0 degree. So let me draw and show you better than writing all these things. Same formula will be same moving here. So let me just draw it. Let's see. So this is your south and north, as I was saying. This one is here again south and north. So let's name it center O, center O1, O2. So for this one, let's make it as M1 as I was saying, and this one as something M2. So this will have some force. This will have force of attraction on this side. That is, let's take F1 for this one, for this side, F2. So this both center will have force of attraction. Now same way, same thing if I consider again, and let's say those are, instead of S here, I'll write here N. That's it. That's what I'm going to change. Same way, M1, M2. Now, this force will differ because this one will be moving away. It will try to push away because this is your repulsive forces. Both are north and north. So they will have one repulsion. So they will feel a repulsion. So let's take this distance as R and R. Now, are you able to understand?
Yes, sir.
Am I speaking very low or it's audible properly?
Yes, sir, it's audible.
Okay, super. Hmm. Now, if I say this both centers, from that centers only we are seeing. Now, like this, if opposite poles of magnet, they are facing each other. Okay, so there will be some field that is M1. That will be field towards this direction, that is M1, attraction force. So the magnetic field which I wrote before, same thing I'll write again. M1 by R cube. Theta equals to 0 degree, same thing. Now, see why theta is 0, because M2 lies on the same axis. If I draw axis for it, this axis line, M1, M2 are on the same point. M2 lies on, not M2, sorry, O2, right? This is O2 lies on M1 axis. And M1 lies on M2 axis, same thing. All these are in same axis. So there will be a couple force for M2 or C2, let's take it as M2 cross B1, which is equals to 0. Because theta is equals to 0, there are parallel M and B. M and B are parallel, so no angle. Now similar way, where it went, yeah. If I take for C1, this is also same. M1 cross B2 equals to 0 again. So M1 parallel to what is this? B2. So theta will be 0. Are you able to understand what I'm doing?
Yeah, sir.
Then what we left? Let's count energy. That's it, over. So energy equals to MB.
So can I
So
just
if I,
scroll up a little? I'll just copy the first before parts.
yeah, sure.
Done, sir.
Done. Chalo. This one also done.
Yeah, sir, done.
चलो तो फिर next करते हैं. If see, this one also we can go same way B1 and how we did for B1 and B2, or sorry C1 C2, same way we can go. U1 we can say here, M2, like M2B and M1 we both will be same, so no need to do that. Just let's end with this. Actually our target is to find force, not this energy we found, it will be same. So for that we can write here simplified form minus mu naught by 4 into 2 m1 m2 by r cube. That's what we can say. So F equals to minus du by dr. So that will give you, both force will be same, right? F1 equals to F2 will be equals to minus d by dr of minus of mu naught by 4 to m1 m2 by r cube. And that's it. It will become 4 2 and this is 2 4. Let it be this one. Minus mu naught by 4 will be as it is. So this will become 6, right? 2 3 is 6, yes, 3 into m1 m2 by r to the power 4. Yeah. Are you done here?
Yeah, sir, done.
Okay. Something is missing in this one. One sec. What is the miss here? Manifolds here. Okay, fine. Nothing is missing. Okay, let's go for next thing. Superposition. Do you remember superposition?
Yeah,
See, like simple. We can say like just simple superposition means for some joining of the lines and all that. Same way, it is similar to that.
yeah, all of them meeting at one single point
Po-
or something like that.
Point. Yes. So, but actually, this is all about like. Let's write. Okay, fine. Let's write. I was thinking like let's skip it, but no, let's write. This is all about like Earth's magnetic field because it is present. Earth's magnetic field is present everywhere. Okay, so in its horizontal component, which is extended like north to south, that is vertical component also there. So magnets, which is like see, like whenever we are placing some magnet anywhere, they get some superimposed with our Earth's magnetic field. Like simply see if obviously there are two magnets, they will get attracted, but there is one more field which is acting on it, that is Earth's magnetic field. So they get superimposed with the Earth's magnetic field also. So whatever we are getting, that is the resultant magnetic field. So in this resultant magnetic field, like so induction of it will become zero. Induction of this B will become zero at this horizontal point. So like see, obviously like there is a magnetic field of this Earth as well as magnet which we are placing and all that. So they will be like colliding and they are pointing. So there is a point for that is called null point. It is the point in magnetic field where resultant magnetic field become zero. This is called null point. So that is the reason north pole of magnet will point towards geographical north. So that is the reason we have north-south direction. North, south, west, east. So if I take a magnet like this, north and south, so they will have some, let's change color here. They will have some magnetic field towards it. Okay. So for this further we'll discuss like tomorrow, maybe day after tomorrow. All this like we have to see like how it behaves when it's like towards tilted towards north and tilted towards south. What will happen? We will see all this. We have to just I'll write so that I'll remember towards north and towards south. No need to write this. This is just for me remembering what I have to teach next. So have you made a note of it, Aditi?
Yeah, sir.
Okay, fine. Then we'll see you on next class. That time I'll teach what
Okay,
will
sir.
happen when it is north tilt and south tilt.
Thank you, sir.
Bye bye.